All right, can you guys see the slides here? Can can
I
people
see
hear?
them, yeah.
Okay, good
I
deal.
hear you, and I see the slides.
Great. Okay, so again, regex, thing that I use all the time. Very powerful tool if you know how to use it. It will definitely like speed up your whatever your text parsing needs are. If you're trying to like isolate entries in a log, or if you're trying to just cut through a help file or something, it's definitely a powerful tool that you can use to your advantage. We'll just move right on into it. So these are the two main sites that I use for any and all things regex. The cheat sheet is just an overview of pretty much all the topics that we're talking about today. So it'll show you how to use character class quantifiers, anchors, lookarounds, all these things, all the things that make up regex, all the various different tools in your toolbox. It'll explain them and give you a brief example. Regex 101, I prefer to the other regex testers like regex hero, because in regex 101 you can actually just hover over you can see the colored portions in that graphic on the left. If you hover over any one of those, it'll tell you what that particular item is doing within the engine. So you can, if you're confused on something, it doesn't make sense why it's not working, you can hover over that and it'll be like, here's what this syntax is doing explicitly for you. It's got the full syntax highlighting, shows you where the brackets end. You can see like the light green there shows where the parentheses match, as well as the quantifier that goes with those parentheses. And we'll get into more of that. I'm just really big on regex 101 because it's pretty much been how I've taught myself to use this as well as I can. So anyway, here's all the topics we'll use today. After I talk about a topic, I'll switch over to regex 101 and we'll go through a brief example and kind of work through like how you would go about solving those. And as with, anything like this, there's a lot of ways to skin a cat. So you can get as complicated or as simple as you want. I'll just show you the ways that you can make the engine work better for you in terms of matching more precisely or less taxing on your processor, which is a big deal. If you're parsing through a lot of text, you actually do need to worry about that. It's something that could really slow down your processing of whatever it is you're trying to do. Anyway, we'll get into the first topic, which is character classes. So at the top there, special characters. These are all the characters that you have to escape if you're going to look for a literal match of those characters. Any of the brackets, question mark, dot star, any of those, if you want a literal match of those things, you will escape that with just a single backslash. So we'll get into the usages of all of those and what they mean as the course goes on, but just be aware that those are all the characters that you have to escape. So depending on what your use case is, there might be other things that you have to escape. For example, if your pattern is in quotes, then you might need to get creative with how you do that. Like if you're searching for a quote in your string and your pattern has quotes around it, you might have to use an escaped quote, or if that doesn't work, maybe the hex code for a quote in the ASCII table, something like that. Just be aware that those are the reserved characters, at least for Perl. There's probably more in JavaScript. I haven't delved that much into it, but I know it's at least these. The predefined classes is something that's specific to Perl regex. You can actually see all of this stuff if you do I forget if it's help Perl or help pattern Perl in Bash, but you can actually see all of these defined, or you can just hover over it in regex 101 and it'll tell you all the characters that fall under those classes. These are the predominant ones that I use. The /W is any word character, so any alphanumeric character, so A to Z, capitals, or 0 to 9. /D is a digit, pretty obvious there. And /S is a space character, and that's any type of space character. You could have a tab, you could have a vertical tab, a carriage return if you're doing multi-line processing in your pattern will work with the /S. And if you use the capital form of these predefined character classes, it does the inverse of that thing that you specified. So a capital/W would be any non-alphanumeric character, so any special character or any space. The capital D would just be anything that's not a digit. And capital S is something that I use quite a bit, because if you have, say, an alphanumeric word, that was hyphenated or had an apostrophe in it, then that will catch all that. You could use a custom class, which is what that first set of square brackets is there. And whatever you define in that custom class is going to be what the engine searches for. So you could have capital A to Z is what I have as the example there. You could further that by saying lowercase a to Z, also within the brackets. Know that the dash is going to go from the ASCII table of capital A to capital Z. So it's actually looking for the numeric characters there. And if you have, it will wrap back around. So if you had like capital Z to capital A, it's going to go back around the other direction of the table and get a lot of stuff that you don't want. So you can put as many characters as you want in a character class like that. Like I was saying earlier, that if I wanted a word that was hyphenated or had an apostrophe in it or something like that, it might be a good idea to use the capital S. But if that word were at the end of the line and had like a period or an exclamation mark or something, then that wouldn't want to be something that I might catch. So in that case, I might make a character class for /W, any alphanumeric character, and then follow that with an apostrophe and then a dash. And the reason I don't do dash apostrophe is because then it's going to look for every word character all the way down the ASCII table until an apostrophe. And does that include a dash? I don't know. Would have to check it out and find out. But chances are it's not going to have the expected behavior. So as you see there, I've got, in brackets, any of these characters. So all of those characters would go into your character class, and I can negate with just a caret symbol. So none of these characters. So all characters that don't match anything within that character set would be matched by the engine in that case. You can use POSIX classes, which isn't something that I get really into, but if you're using, I guess I could see some use from this if you were using regex from a non-standard terminal, like maybe K-shell or something, something that it's a little bit more POSIX heavy. Anyway, not something I use a lot, but it is there if you wanted to use that. And all of this stuff right here is also on that cheat sheet. So if you needed a quick reference to any of this stuff, then it's right there in the cheat sheet for you to check out. And as I mentioned, there's a lot of ways to skin a cat. Like if I wanted to match a capital A, I could do that with just a capital A. X65 is the hex code for the capital A on the ASCII table, which I'm sure most of you, if not all of you, already know. You could use the lowercase w or the capital S, or not B, and of course that would just match everything except for a lowercase b. I've got a little example there. On the right, you can see the whole pattern is matched there. I'm searching for just one character at a time. So the first character class is lowercase a to Z. Second character is not any capital letter, which would match the B. And then I have any word character, followed by any digit, followed by any non-space character, and the dot is just anything. Any one character is a dot. So I've got 6 characters defined there. 1, 2, 3, 4, 5, 6. And that matches that whole string there. So with regex, you'll need to know that it's going to start matching at the beginning of your pattern based on where the cursor position is. So if I had 6 characters over and over and over again that match that string, it's going to match every one of those unless I use anchors to define a position within the string. And we'll get into more of that a little bit later. But anyway, these are character classes in a nutshell and how those work. So does anybody have any questions before I move on to an example? Okay. So as you said, X41 does indeed match the capital A. And you can hover and it will show you like X41 matches the character capital A with index 41, base 16. So 65 was the example I had there, and that's base 10. So just be aware, that the X or /X number is going to be the hex code for the character in the ASCII table. Good catch. All right. So for this example, we want to match that first line, make a pattern that matches all of the characters listed in this line. So we know right off the bat, word characters are going to match just about everything there. I also have space characters. So let's include a space, or excuse me, we'll make a character class for all of these. So a word character is going to match most everything. And we got space characters. I see a couple special characters in there. So we could include an exclamation, @ symbol, and a $sign. Or excuse me, a hash, shebang, whatever you want to call it. And that matches everything, or excuse me, doesn't match anything on the line after the colon. So the space is kind of a gimme there because there's a space on both lines, but you can see that it's not going to match anything after that. We can be as explicit as we want to define whatever we need to match versus not need to match. So I mean, we could catch everything here with just a dot, and that's going to catch all the stuff that we don't want to catch. So if you want to exclude it, we could do something like that. I mean, really, you could make this even simpler and say not $, %, or caret, right? And if you'll notice, before I mentioned that you would have to escape these characters, but whenever they're within a character class, you do not. So long as the character class is defined properly, it will take these characters literally. Now, that's not always the case, because if I put a dot, well, I'm wrong in this case. It is going to match literally a dot. But if I have a dot outside of the character class, it just matches every character. So just keep all that in mind, that the character class is going to define everything quite literally. The only exception would be if you had some kind of browser, or not browser, like a command line interpreter that would interpret those commands, or excuse me, those characters, like say a bash shell would interpret some characters a specific way, and you might have to quote it, but from the raw engine point of view, you wouldn't have to escape things whenever they're within a character class. And I guess that does it for character classes. Anybody have any questions? Anything that doesn't make sense, or should I move on? All right, nothing heard. I'll go ahead and put the next example in here, and we'll move on to quantifiers. So quantifiers. This is whenever we want to add more than one of something, or even zero than one. We're just specifying how many times we want a certain character class or capture group or what have you to match. So you can see the table on the left there. Plus is going to be 1 or more, star 0 or more. We can also specify a custom range with the curly braces, and that's another one of the reserved characters is the curly braces, not the comma, but the curly braces are special characters, so you'll have to escape those if you want to use them literally in your pattern somewhere. We can say a minimum or a maximum using the curly braces through x comma y would be, say 1 to 5, or up to y, or minimum of x. So the lazy mode with the question mark is pretty important to how the engine is going to match something. By default, the engine is going to be in what's called greedy mode, and greedy means it's going to use as many characters as necessary to make the match. It's going, like if you have dot star, it's going to match everything. If you have dot star question mark, it's going to match probably nothing unless you have something else after that it has to match. Because dot star means 0 or more characters, if you make it lazy, it matches on a null string. So keep that in mind whenever you're creating your matches. And also, the engine is going to stop matching as soon as it can. It's trying to make that match as quickly as possible. So if you have something that would match multiple times in a string, and you're not using anchors, it's going to match every time. If you're using an anchor, say from the beginning of a string until it finds your pattern, but that pattern appears multiple places on the line, it's going to take as many characters as it can to make that match. So you can reverse that functionality. You can see the examples that I have on there. I have a non-space character that takes at a minimum of 3 characters. On the top there is only making one match from that string because it's 6 characters. And the bottom, I have a question mark, so it's using as few characters as it has to make that match happen. So it's actually able to match that string twice because the question mark puts it in lazy mode, and that makes it use only the 3 characters. Now, if I had 7 characters, one of those groups or one of those matches is going to be 4 characters long. So how that functionality actually works in practice, you should play with and make sure that it's going to have the desired effect, because it might surprise you. It might not always be as intuitive as you think, but thankfully, at least all the engines are built alike, so there is some continuity to know that if your program is using Perl regex, it's going to work just like any other Perl regex tester like regex 101 would show you. So a little bit back on the character classes down there at the bottom left, I've got a pattern, and you can see what it matches, and we could talk to that a little bit. The HE is literal HE, and then I've got a character class for L or N, and one or more of those characters. So it's going to match both the N and the L, and then it'll match the O literally. And then I have a space and any number of alphanumeric characters, followed by an exclamation point. So it wants to make the match. It's going to do everything it can. If a match is possible, it will make the match. So that's how that pattern is matching that string. So are there any questions, or should I move on to the example? All right. So I want to match something, or that whole first line, make a pattern that matches this whole line, and then I don't want anything that matches after the colon on that. So it's the same pattern as before. This time we're just going to do it with quantifiers. So of course I could do dot star and just match the entire string on both of them, but we want to exclude those other characters, right? So I could do just like I did before and use a quantifier for that one character class that we had, which was really just the simplest way to do it was not $, %, or caret. And that doesn't match anything after the colon in the second line, and it matches everything in the first line. And we can do this as many times as we need to. You know, like if you had multiple character classes with multiple quantifiers, that's fine. You could even have nested, like if you had a capture group within a capture group and you wanted one to repeat but not the other, you could do that. And I'll show you more on how to do that as we get into capture groups and that part of the lesson. Pretty simple so far. Everything makes sense? Yep. All right. So the next topic is anchors. So anchors are how you would not only match in a position on the string, either from the front or from the back, but you can also specify like word boundaries with the /b. Anybody have a guess as to what the /B might be? All right. Just it works like the other character classes, so it would be something that is not a word boundary. And I can talk a little bit more than that. A word boundary is kind of whatever you specify it to be, but you can hover over in regex 101 and it'll show you it's basically anything that like ends a word. You know, so if you had, you can see in the example I've got over there at the bottom right, what's a word boundary. So the /b on both sides of the non-space character is going to define a word boundary as a space. And I've got it, you know, showed right there where you hover over the /b, and that's anything at the front or end of a line. It's what the $ and the carets are, that is either followed or preceded by a word character. or it could be a non-word character followed by or preceded by a word character. So that's going to be our word boundaries, and that's how you can kind of hone in on what you're trying to highlight. So because all of these things are being taken into consideration, you need to be aware that if I had a space after that question mark, I mean, is it going to be included in the word? You would have to test that and be sure that you're not going to catch stuff like that. If you were only trying to catch word characters, dashes, and apostrophes, best practices, the character class that I mentioned before, or you might get some things that you're not expecting. So the /k is kind of an odd bear. I don't really use it very much, but it's a way that you can match on an entire string. However, it's only going to store the match after the /k. So it's keeping out all the things in the match that are prior to the /k. So when I say put into memory, I mean that the entire match is stored in a register, and most of the time that's going to be $0. $0 is going to represent the entire string match. So like if you were to have a pattern that matched a string, $0 would represent where that match was in the string. So if you had just a dot star, then that whole line is going to be saved into the $0 register. Like I said, it depends on what program that you're using is how you would reference this stored bit in memory. Like a lot of times, like say Notepad plus will have $1 or excuse me, not dollar, but /1, \1, or \0, and we'll get more into the numbered ones, but know that the entire match is going to be the 0th register there. So anyway, the bottom left there, I'm using the /k to match the whole string, but it's only going to include match this part as the $0 in memory. So we can split that as many number of ways as we wanted to with the numbered registers like $1 or /1 with capture groups, and we'll get into that a little bit later. As far as anchors go, as I mentioned, caret is line start, $ is line end, so you can save yourself a lot of cycles in your processor if you're specifying your anchors correctly. Like I mentioned, it's going to match on every pattern within a string. So if you're looking for just the word start, then it's going to find every instance of the word start. But if I have a caret start, it's only going to find it at the beginning of a line, not when it's somewhere else within the line. So some unique behavior that could cause you issues is it's going to only match once in this instance. Like if I had caret start followed by dot star and then a word character, right? It's only going to match the word start and then the first word character that it comes in, that it comes across. It won't match every word character after that. And the reason for that is, I mean, it's just how the engine works. If you were looking for multiple instances of a pattern that is anchored, you're going to have a hard time. That's a lot more difficult to do, and I haven't found a functional way to do that as of yet. So if you're trying to match everything on a string, anchors are probably not going to be where you're trying to go. But if you are only trying to match one time on a line, you could save yourself a lot of processing power by using anchors, either specifying it from the beginning or from the end. Now, know that specifying something at the end of the line is going to take more processing cycles than at the beginning of the line, since we read left to right, and computers, at least the regex engines that I've worked with, also read left to right. So you'll save yourself more processing time starting from the beginning of the string rather than looking at the end of the string. So word boundaries, I've kind of touched on that a little bit already. If I wanted to match the word some, but not something or someone, I could surround some with /b, and that would only match on the full word some and nothing else. So if you had, well, I guess you'll see more of it in the examples. But that is anchors. Does anybody have any questions on anchors before I move on to the example?
Is there a little k that would rather take everything from before the slice?
Be sure this isn't the right test. Okay, so now we're going to match a whole line with match as the first word. Easy, right? You say match. That's how you do that. And then we want to match a whole line that ends in match. Easy breezy. Just use the $sign and it goes towards the end of the line. And finally, we're going to match only the stuff after match in a line. So we can use the /k there and just say dot star. Or if you wanted to only match the stuff after the /k, like I mentioned, it's the last /k in the line, or yeah, in your pattern. So it keeps out everything before the match as well as match because we had a secondary /k there. And you can see that this engine doesn't accept a lowercase k, just the token is incomplete. It doesn't know what that is. Pretty straightforward stuff. Yep. And when I was saying word boundaries, like if I had, /b word, it's not going to match on sword since that's outside of the word boundary. But as soon as I get rid of that s, now it's the complete word, and it goes. Any questions on that? Pretty straightforward. All right. So lookarounds. As I mentioned really early on, the regex engine is going to match based on the position that your token is within the pattern. So lookarounds are special because it doesn't move from the position where your lookaround is. So as you can see in that top right example, I've got the word text with positive and negative lookarounds on both sides of it that are pointing in the direction of where the word text is. So what that means is the positive lookaround, which is just the question mark equals, it's looking forward from the very beginning of the string and seeing if that position is followed by text. And conversely, the positive look behind, which is question mark less than, yeah, equals, is going to look at the end of the word text where that cursor position is and look backwards and say, is text there? Great. So it's a really long-winded way of making that match, but it's a great way to match on certain things in certain situations. So in that second example, we have match this string and then don't match because this is here. So I can match that string by saying match, and then a negative look ahead or question mark exclamation. With the negatives, you just replace the equal sign with an exclamation. That's the easiest way to remember it. And it will not match at all on that second string because of the negative look ahead. It looks from the end of the word match and sees space because this is here and says, nope, we're not going to match that string at all because of that negative look ahead. And the third example at the bottom right, the top line will match and the second one will not because we have a negative look behind for won't space. So if match is preceded by the word won't, then it will not match in the engine. So there's a lot of really useful things that you can do with lookarounds. And say, for example, you wanted to match on a command like say curl, but only when curl matched a specific URL. Then you could have a positive look ahead that says, dot star and then the URL. And the reason that works is because it doesn't matter where the URL is in the string, just somewhere ahead of it, it's going to have that URL, and you've got curl, so you're looking for the command, and somewhere ahead of it, you can mix up the options however you want, and the engine is going to find it because somewhere ahead of it, there it is. Now, look behinds are a little bit different because there's something called a zero width assertion. And that's just a fancy way of saying you can only have fixed width look behinds. The reasoning for that is because it will go into a recursive loop and crash your engine if you try to use non-standard width or non-fixed width look behinds. So in the example that I just gave, if you were looking for that curl command, you would have to use a .star URL and not a look behind for curl.star, because the engine is going to just fall all over itself. Every single character, it goes back and looks for that whole world, that whole pattern that you define and look behind, and it breaks it. It breaks it in catastrophic ways. It's probably going to crash your program if your program even allows it to do it. But most of the time, it's just going to give you a warning and say, you can't do that. So that is effectively how lookarounds work. Again, it matches from the position it is on the string, and unlike a traditional match, it doesn't change the cursor position as it matches. So you'll also notice that lookarounds do not include themselves within your match. So I'm just matching the word match, but if I had match.star within a lookaround, it's still only going to have match. So just keep that in mind whenever you're going about it, because you would need capture groups for that, which we're about to get into, but they're just know that they're a little bit different than how lookarounds work. Anybody have any questions on this before I go to an example? All right, regex 101. We're going to use positive lookarounds for both the word isn't and fun, and only match for the word regex. So we want to match that first line, isn't regex fun, and then we don't want to match regex isn't fun. So if we're only matching for the word regex, that's going to match both lines, of course. And we can use a positive look ahead for fun. And that matches that first line. So if I wanted to match or not match the bottom line, let's say I wanted, like anything there, line, I could say match regex when it is not followed by isn't. And that's how you could do that. If I wanted to include both isn't and fun, then I could do a combination of both. So I could say like somewhere in front of it, .star fun. So that's going to match both lines. And then a negative look behind for the word isn't. So the engine is going to look at the position of the R in regex before it for isn't space, and because that top line has that there, it's not going to match. But it's a way that we can match that bottom line if you wanted the inverse functionality of what the initial challenge was there. So just another tool for your toolbox. It's incredibly helpful in my opinion, because you can specify multiple things. So if I wanted to say somewhere in front of it is fun, but somewhere in front of it is not, isn't. So with both of these look aheads, it's looking from the X in regex. After that position, anywhere in front of it is not the word isn't, is still going to search from the end of that X. So just be aware of that functionality. It's not progressing the character spot on the pattern anywhere. Does that make sense? Everybody understand that concept? Was I going too fast? Nope. All right, go back. So here's the second. Since that first one was a little easier, we're going to use negative lookarounds to match some. So some, when it's not followed by, body once told me. All right. So that first line is not going to match because of the negative look ahead. We're also going to say when it's not followed by thing. So again, like I was showing you, put that in the same position and it's going to be interchangeable. Like I can move this look around in front of the other and it doesn't matter. Still works the same way. So you can match this bottom line without the other two middle lines using look aheads that way. And I guess everybody gets that. So we will move on. Okay, so capture groups, I was mentioning before how the engine is going to put your entire match in the 0th register in memory. And you can reference that with capture groups, a special type called a back reference. Back references you can use within your pattern to match something that was previously matched on that string. So you can see I've got a capture group, which is just some pattern in parentheses. At that bottom example there, it's got this in parentheses. So that's going to store the word this every time it sees it in one of those numbered registers. So I have a positive look ahead for back reference of the 1th register. So it's going to match the string that's in that text string there, because this, which is saved in the 1st register, positive look ahead, any number of characters, so somewhere else on that string, it's going to match this again. So you can use back references to match the same thing twice if you had a particularly complicated thing that you just didn't feel like copy pasting or whatever. It can just help you to simplify your pattern so it's a little bit more readable with back references. And these capture groups, the numbered ones or even the non-numbered ones, you could use to say like a find and replace, and you can reference the full match or the 0th register, and just replace the full match or just copy it to a file, what have you. But know that each of the capture groups are going to go into the numbered registers 1 through, I think 0 is as high as it really goes again. Or excuse me, it's 0 and then 1 through 9 for all of your numbered registers. And we have a non-capture group, which would function just like a normal match. But the difference is you can put logic in a non-capture group. You could do it with a normal capture group too, but it's just a way for you to use the functionality of logic within capture groups in a way that doesn't actually save that string to a numbered register. And there's a little bit of nuance to this. Like you can see that top regex that I have there is going to match this, whatever it's followed by, and this, or this. And you've just got the normal like pipe symbol there to specify that you want or within that non-capture group. So you can see there that the whole thing, this and this, or this or this, are always register 1. I've got a snippet of regex 101 where it shows you group 1, which is that 1th register in memory, is going to be this and this, and then in the second match, this or this. So you could reference 0 for the full match, or you could match the this or this register. It's whatever you would want in that instance. So sometimes it's only going to save, it again depends on your engine. Like my use case is going to have the entire string match in the example that I have here. Since it's dot star this and this, it's going to save everything. So your full match in regex 101 is, it shows that top one is store this or this, it's greedy, so this or this. And the reason I had that in there is if I had a question mark after that $star or dot star, it's only going to match up till that question mark in that first line, because that would be the lazy functionality that I was talking about before. Since dot star is greedy, it's going to match all the way to the end of the line the last time that it sees this and this. And it's going to store that full thing in your register 0. So just be aware that, again, like I was saying, whenever you're using the greedy form of dot star or whatever quantifier that it's going to go as long as it can before it finds that match. And this is just kind of talking about what I was saying earlier, how I can't have multiple matches on that line because I'm using an anchor. So if I wanted to match both this or this as well as this and this on the first line there, I would need to take out that beginning portion outside of the capture group, because that anchor is forcing the engine to only match one of those. It's going to match one and then it's done. So on that bottom line, you can see it's not matching this and something else because neither of those fall within the two things that I have separated by the or the pipe symbol in the non-capture group. So it's not going to match this and something else because that's not specified in your pattern. So if I wanted to capture, like switch the functionality and only capture and this or this, then I could put the question mark colon on the first capture group. But notice that it doesn't turn it off. The way that I have it in this example, the and this or this should not be captured because it's in a non-capture group, right? But because it's nested within a capture group, you can't turn that functionality off. So it saves that full pattern within the capture group. No matter what you specified as the non-capture or capture, it doesn't matter. It's going to save that whole string as group one. Now, if I had made them both capture groups, it's going to store the whole thing as group one, and then that latter part and this or this as group two. So just be aware that that second portion, however you want to nest it, is available to you unless you just turn that functionality off. And it's just something I recommend for the sake of saving memory and in some cases processor power. So I already talked about back references. That one is fairly self-explanatory. And the only logic that you can really use is the pipe symbol to specify multiple types of patterns within a certain capture group or non-capture group. So we're getting a little bit more in the weeds here, applying logic to the patterns, and it's a little bit more complicated still whenever you consider how anchors will interface with the engine and either prevent or allow whatever functionality that you specify. I might have gone over that a little bit fast, so if anybody didn't understand something, I could explain it again. Anybody got any questions before I move on to the example? All right. So we'll switch over. So the instructions, I'm going to match and capture the first word of all words on the line. So as I mentioned before, if I just put word, it's going to capture every instance. So we want to capture it. I have to use an anchor. So if I'm going to capture the first word, as you can see, if I don't make the dot star lazy there, it's going to go to the last instance on each line. So I have to specify lazy with a question mark. And then it goes on to say, but only the whole word word. So I could do that a number of ways. I could do that with lookarounds, but the easiest way is probably just to do it with /b for the word boundary. So as you can see, that last line moved over to the second or the full word because the first instance of word was words. So by specifying the word boundaries there, I'm able to capture the first word of all the words on the line, just the whole word. So anything else is going to be ruled out by the engine. Okay. So the second line, I'm going to capture the last word, but only the whole word. And I've already pretty much done that. All I need to do is get rid of the question mark, and that makes the engine greedy, and it goes to that last word again. All right. So this last one is a little bit more complicated. We're going to capture all whole words containing word. Boom, we got that part. And then we're going to capture words with double letters on the line. So how would you go about capturing something that is a double letter? You could try a character class for, say, any double letter. So that would be A to Z or A to Z. And that's going to look for any any, what do you call it? Any character, any letter, either capital or lowercase, and then we have to make a second of that, right? So we could do a /1, and that's going to look for that first capture, which would be the first letter, but it doesn't work yet. So it's something we're going to have to work through a little bit. We're also looking for, excuse me, I wish I intentionally didn't save my patterns on how to solve these so we could kind of work through them together, and you can see how it's a really interactive process to figure out how you would solve something like this. So we're looking for the whole word containing word, or excuse me, all whole words that contain word, right? So really we don't need this boundary anymore, because now we're looking for anything that even contains the word word. And from there, we could actually include a secondary group, make this first one a non-capture group, followed by any word characters, right, on both sides. Now we've got all of the whole words that contain word, but we still don't have the double letter one. So the reason that's not working is because this is not a good pattern. So we need to find a way to make it look for double letters. Anybody have any ideas of how we could look for a double letter in this case, or what I might be doing wrong? So, as I mentioned before,
Can you make word a grouping, essentially? All the letters of word within brackets or something like that?
I could. Sure.
And then add a plus afterwards? Plus?
Yeah.
No?
So now I've got anything that contains any of those characters more than one. So you can see that's any O is going to have that in there. Any word that contains any number of these characters back to back. So because I've got an O or an R, or excuse me, let's see, what do I have? Let's look at the word containing and figure out why that might match. All right, so because any of those letters in word, I see an O, which is surrounded on both sides by any number of word characters. So that could be 0, really. And so that's why that doesn't work, because it's only looking for one character. So what if we made that?
Really? Okay.
What if we made that 2 characters, right? It's looking for anything that's 2 characters long within that bracket. But again, because it's looking for any of those letters, 2 or more of them, it's still going to match on, you see, OR is working there because the O and the R are next to each other in a row. And why would double match?
Because it's got a D and a O.
There you go.
Surrounded by, well, but in front of the D is a space, so that's not a word character.
No,
So,
that's correct. But since we're looking for star, it's going to be 0 or more on both sides. So because it has the D and the O next to each other, we've met the criteria of 2 of those characters. So let's back up a little bit. If I wanted to match 2 of the same characters, how would we do that? First of all, we would need any word character, we'll just say W for the benefit of a doubt here, followed by that same character, right? That's how we would use back references in this case. So if I were to use that, followed by W star, then that's going to match all the words that contain more than one of the same letter, right? So I could instead just include this in my pattern. And I mean, we could go about this any number of ways, but based on the old pattern and this one, you could work it with the OR gate logic to include both of those in there. Just be aware that this back reference /1 is only going to consider this first capture group. So if you start nesting it like we would have to match our other use case of word, right? It's going to turn into, something else. Whoops. Now you can see /1 is still going to be the word character, the entirety of it, but that group 2 appeared, and I can get rid of it by making that a non-capture group, and that still works because, as I mentioned before, you can turn on the functionality of capture groups but not turn it off. But when I try to go to /2, there is no /2. It doesn't exist unless I turn it back on. So, back to the original problem, we would know that it has to match all of this, 2 words, right? Or excuse me, 2 word characters that are the same, which we specified in our character class, followed by this. So we can now, it gets a little bit more confusing when we add the OR gate. Because now what have we done? Why is it not matching word? So this 1, right? It's not in the right spot. So how about now? Have we accomplished the goal? We have not. You can see how things get a little fuzzy. I promise this is possible. It's just you really need to look at the pattern and how you're going to match based on that. For an example like this, it's probably going to be a lot easier to try to do 2 different patterns if you have that within your control. It's a pretty difficult problem to solve, but it is solvable. Anybody want to keep cracking at it, or should we just move on?
So was the original challenge to get the word word with any potential duplicate letters within it?
So I wanted to capture all whole words containing word, so wordy, swords, or words, any of those, as well as any words that had double letters. So not necessarily word, but like all or letters, something that had more than one of the same character.
Okay.
That was the original intent. And I kind of wish I had saved the pattern that I figured out yesterday, because I just cannot remember for the life of me how I solved this. But we can just move on. It is possible, but I just wanted you guys to see how the logic worked within capture groups, and also how to turn on and off that functionality so that you can save what you want and only what you want to certain registers. Like if I wanted to capture the entirety of the words, it would look more like this. So before we weren't catching those other letters in our numbered register, it was all going to the /0. So now that the whole thing is in there, we know that it's going to capture that whole word. So that's essentially how the capture groups work. You can nest them all kinds of crazy and just make it something that will make your eyes bleed, and Lord knows I've done it. You can make it as complicated or as simple as you need to, but just know that all of these tools can really help you hone in on exactly what it is that you're trying to match. Anyway.
So are you almost there with your goal, but you've got that duplicate character logic negated, or said not to be a capture group? And
because
so in the beginning of that, the question mark colon, doesn't that make that a non-capture group?
So it would, but as I mentioned, you can't turn it off. So within this first capturing group that I have here, it's going to capture everything in there, whether or not I turn it, if I have the other nested capture groups as non-capture groups. So you can see I can turn off the non-capture, and suddenly it goes from register 1 to register 2. So I've got the word there, right?
Mm-hmm.
And that's going into register 2 because it's within this second capture group. The third capture group is just /W, right? That's the word character that we specified. So if I turn this off, excuse me, if I turn this off, this is looking for the entire match of register 1, right? It doesn't know what, oh, and there we go, there's the problem. Since it doesn't know what register 3 is, because there's only 2 registers being saved here, I just have to reference the correct spot in memory. So you can see here that because that second capture group, it's a non-capture group, so this one is really the second capture group, which is just that word character. So now we've solved it. I just had the reference wrong. It's looking for that word character a second time. So any double letter that it captures, like all or letters, is going to be included. So there's no way around saving that L or what's the other? I had letters in here, yeah. Like letters, it's not gonna, there's no way to not save that second capture group of the L or the T for double letters, but it doesn't matter because I can reference the entirety of all with group 1, right? So there we go, we've solved it. I was just using the wrong back reference there. So
Don't forget to copy that.
yeah, I will actually put that in my notes for the next run if I have one of this class. It definitely takes some doing to work through all the troubles that you might have, but whenever you know the limitations of the engine, it can really help you to hone in on the problem. And another issue that you might notice, or another way that you could find the problem sooner, is in this little explanation tab here at the top. So it will walk you through from start to finish exactly what's going to happen step by step in the engine. And if you have something in there that doesn't make sense, it's going to tell you, it's going to yell at you, and it'll also give you some needy or helpful clues like, you know, this is greedy, or gosh, what are some other things it might tell you? If you were to have an anchored set that's looking for a certain string, it's going to tell you when it's only going to match the first or the last instance based on, you know, greedy or whatever. Just, it's another place that you can look for plain English understanding of what you're doing and what the engine is interpreting it as. So definitely look to this block, as it will help you if you can't figure something out. And again, you can always hover stuff too and see what's going on there. You know, it'll like nicely highlight everything for you. It's looking for these literally, looking for what's in the second capture group. Any word character is this character class, match a single character in the set. So a lot of tools available to you. You can also see how many steps it takes in memory right here. We've got 18 matches, over 4,000 steps for it to actually accomplish all of this. And you can, I forget where it is, but there's some functionality of regex 101 where I can walk through literally character by character, and it will give you all 4,380 of those steps, one after the other, so you can scroll to exactly the character position that it is matching where you don't want it to, or the reverse. I don't remember where that is on here, but it is a functionality, I promise you. All right. So long-winded explanation of capture groups, and we will move on to the next portion if nobody else has any questions. All right. I don't have an example case for flags because they're pretty straightforward. It's just something that you can use within the engine to change a particular behavior. Like, for example, regex 101 is by default case sensitive. You might encounter from your use case that your engine is not case sensitive. But if you wanted to change that functionality, you could use the I flag. You could also change the functionality of matching on multiple lines. Like if you wanted, say, one line to have one pattern and then the line immediately following that to have another pattern, you could use multi-line mode. I've got probably in parentheses there because it matters which engine you're using. For Perl and Python, I know that the M is multi-line mode, but it's something different in JavaScript's engine, and I can't remember what it is off the top of my head. But just know your engine, know your program, and how that is going to work, what you're trying to do. Regex 101 also has all the engines, so you can just select whichever one you need to use, and as always, just hover things, try things out, and it will show you the normal behavior for that particular engine and how it would interpret whatever flag. The question in will switch the functionality of capture groups with the exception of named ones. And I've got the brackets in there for named ones just to show how a named bracket might be used, or excuse me, a named capture group. And that's just if you needed more than the numbered capture groups, you could use named capture groups to expand as many as your heart desires. You could have infinite number of capture groups that way, assuming that you have the memory for it, of course. Just know that switching the functionality of capture and non-capture would only work except for those named ones, because why would you have a named capture group if you weren't going to reference it? You can use the question caret to unset all the flags that you have specified within the pattern. So in my example there, I had turned off ignore case and then turned it back on with the -I. So I could have unset that flag and all flags with the caret there. So know that that might not always be the best case, because there are some flags that are set by default based on the engine that you wouldn't want to turn off. The cheat sheet that I had at the beginning of this slideshow will explain all of those flags. This is just the most used ones for what I've used them for. But know that they are a tool that's available to you, and while they might be kind of a niche case, they are useful in many ways. Any questions on flags? Nope. All right. So, some tips and tricks. I mentioned earlier in the slideshow that we could look for a certain command with arguments in any order using the positive lookaheads. Now, it's not going to capture those in a particular register, but you could put that whole thing in a capture group and capture the entire command that way. With just command .star and capture the whole argument that way. Or you don't even have to use a lookahead. You could just use a normal capture group and then .star argument whatever. But because I'm looking for two arguments in any order, the lookaheads work there because they're both starting to look immediately following the D in command. So if I wanted to capture one of those arguments, I could do so, but I couldn't capture multiple arguments in any order within the same pattern. And that's just because of what I was talking about before with anchors. I'm basically anchoring those arguments after the D in command. So if I were to have multiple in any order, it's only going to match on the first in that position. I would have to specify, this is where this is going to show up in the line, and this is where this is going to show up in the line. So like if I knew that argument 1 was always going to be before argument 2, then I could get rid of the look ahead portion of that, right? And that would work. But this is just one way that you might look for a command when it's only using a specified number of arguments and you don't know the order of such, because the engine will go back after it makes that positive look ahead to where it started on the line. So sometimes there are engines that will allow you to go back to where a specific match happened. I'm not teaching that because it gets really in the weeds, but it is possible to do that. It's just incredibly involved, and it's probably just way too much for what I would consider kind of a beginner's look into regex. And I mentioned before the zero width assertion with look behinds. So if you wanted to do the reverse with look behinds, that's going to break your engine and crash your program if it lets you do it, because it would cause the infinite loop looking behind after every single character, and it's bad juju. It's going to max out your processor and set your machine on fire or something bad. And if I wanted this argument but not that argument, I can nest my look aheads, or my look arounds rather. So I can say, you know, argument with a negative look behind of that. And because it is a fixed width, it's only 4 characters, it knows and will process on that. And I could have done this with a /B if I wanted just argument, you know. But if I wanted specifically not that argument, but say this argument is okay, then that works as well. You know what I'm? Maybe that would have been better explained with a visual guide. But just know that it's the negative look behind there is only not going to match on that argument. Everything else is going to be fair game, so long as argument is somewhere after command. It will match. Okay, and it's taking forever to parse this file, right? Anchors can save you a lot of time. If you're going through a gigantic file, anchors are going to save your life. It causes so much more time whenever it's looking for a certain pattern anywhere in your text. It's going to start looking at every single character and say, hey, does my pattern start here? So if I've got a gigantic capture group of OR logic things, then it's going to go through every single character and see if it can start making that match from there. So things get really hairy when you have, like, you know, dot star and then some pattern with a lot of OR logic in it, because it's going to go every single character all the way ahead and try to make that match every single time. So you can use anchors, but know that some things aren't going to help. Like if you use anchor and then dot star, that didn't do anything. It's saying, you know, from the start or end of the line, any number of characters and then pattern. That's essentially doing the opposite of what you were trying to do, because it's now taking even more processing power to start from the, not taking more, but it's not taking any less either, because it's starting from the front and going all the way forward, all the way to the end of the line. So just know that you need to be as specific as possible without ruling out matches that you don't want. And that's the best way to create the regex that's going to work for your use case. I hope I explained that well. I feel like I kind of tripped over myself a little bit. Does it make sense why caret dot star pattern isn't going to save you any time? I hope it does. Okay. Well, we'll move on then. Okay. And I mentioned earlier on, like if you wanted to use something that had quotes, like if, say, you're using regex within Python or on the command line, and you had to put your pattern in quotes, you could escape them. You could use the hex codes for quotes. I've actually used what's there at the end with the word patterns. I've used that before, sending a line to a webhook for Discord. So like trying to curl something, you know, I have like the single quote in the string and then another single quote or an apostrophe, whatever, within double quotes, and that works fine. So, you know, just know your engine, know your program, and you can make it work one way or another. It's just a lot of ways to do it. I want regex to find the noun in this sentence. Regex does not know grammar. It doesn't know a participle from a noun or an adverb. It only knows characters. So if you had a gigantic word list within a capture group or a non-capture group, whatever, that was just ORed out, then yeah, you could do it that way. But it's going to be very processor intensive to do that, and it's probably just not something that's going to be feasible. So just be aware that regex doesn't know grammar. All right, so these are all the examples that I used before, with the exception of the challenge. So we'll go and do the challenge real quick. So 3 conditions here. I want to match for index.html and capture the base URL only. So we'll escape that period because it's a special character. So we're matching index.html. That happens. But I want to capture the base URL only. So what does a base URL look like? That's going to capture the whole line, but how would I capture just the base URL within that string? I mean, I could have it quite literally and say done it. But what if I wanted to capture any URL? Like, we know that it might not have www on the front, might have something else. I mean, we could say there's also websites or URLs that are just 2, like instead of something.something.something, it's just 2. But we can create our capture group functionality based on how we know URLs look. So we know it's always going to be a word character, right? We're not going to have any special characters within our within our URL, at least not that I know of. I know maybe emojis are a thing somewhere in in URLs, but ultimately it's going to be a word character. We know it's going to be 1 or more, and then it's going to be followed by a dot. So now we have, because it's greedy here, the dot star is looking for as much as it can, and then 1 or more, followed by as much as it can. So that's why it's only getting the E there. So if I were to follow that with, we know that this is going to be, the URL is going to be followed by a slash, right? So we know that that's going to be there, and I have to escape it. And now we've got e.com. So I know that we're also going to be preceded by the slash, right? So now I've got 2. And what I can do here is, because I know the identifier is going to have at least 2 portions to it, I can quantify that and say 1 or 2 word character, any number of word characters, followed by a dot, and I've got 1 or 2 of those. So if this were just website.com or website.eu, it's still going to match, because I'm specifying either 1 or 2, followed by, again, any number of word characters. And I could take this to another extreme if I wanted to, and say like 2 to 3, and then say 0 or 1 periods, right? So now that's maybe a little bit more readable. And that's just walking through this. I've got any number of characters, so HTTP or HTTPS followed by 2 slashes, and that's going to be followed by this capture group, which is specifying the entirety of our URL. And nested within that, I have a non-capture group of any word character followed by a dot, 0 or 1 dots, and I've got 2 to 3 groupings of that. And that's going to be followed by a literal slash, then some number of characters somewhere in front of it. We're going to see index.html. And that's probably the easiest way to make that happen. We don't even have to match on the whole string. If we want to, we could, keep out. And that way we're matching the entire URL, but we're only capturing the base URL. And that's the easiest way to do that. Does that make sense? Was I going too fast? Anybody confused on any of that? All right, we'll move on to the second portion. So we're going to capture only the subfolder names. So we've got folder, subfolder, and another subfolder. So the best way to go about this might be so what's going on here? Why do I have folder and another subfolder but not subfolder? The best way to do this might be lookarounds. So we can look and see, do we have a slash behind? Great. If so, capture that. But now this is capturing everything, including the slashes. So we can use another lookaround to get rid of both of those slashes. But we're capturing folder, and I said only subfolder. So if I were to change this positive look behind, or even just add one, and say a negative look behind for a slash preceded by a word character, another word character, and a dot, right? Boom. Now we're only capturing the subfolders here. So this one's a little tricky because if I change that to com, now it's capturing folder again. And because this negative look behind has to be fixed width, the only way that I can do that is with an OR group that will instead include a third character. Does that make sense? So because this negative look behind is looking for either 2 or 3, it's still fixed width because I have the only 2 cases that are possible identified. But if I were to use W star, now that's any number and the regex engine breaks. Does that make sense to everybody on how I capture the subfolder names? Okie dokie.
Silence equals yes.
All right. And for the third challenge, we're going to match only the file path after the URL and capture the file name. So we've already done part of that. We captured that first part, right? We had the URL, and we're only matching the file path after the URL. So I can make that a non-capture group, and now the URL is gone. So it's easy enough then to capture only the file path after the URL by just changing how I have my capture groups. So because I already had that regex built for the URL, it's just as easy as switching around how I'm capturing things to change that. And if I wanted to exclude that first part, I could just put another keep out before my capture group, and that's how you would do that. Pretty much that simple, or maybe it's not that simple, but that's how you would go about it. So again, this was just me giving some more like hands-on examples. That was the feedback I got from the first run of the class, is I had a lot of information without much showing it in practice and how you would work through problems and how to actually like hands-on use these things. So I wanted to include that, and I hope it was helpful. We kind of tripped through it a little bit, but we got to the goal there. I think I missed somebody in chat. Delimit, yeah. So you got it. You got it, Nicholas, with the double slashes and the slashes. You would just look at the line and how you're defining it, and then just limit it as much or as little as you need to based on the information that you have. Does that make sense to everybody? Okie doke. I will stop sharing. So I've gone over all the topics. Hopefully you understand regex a little bit more and how to use it. Just again, I can't say it enough times, be aware of your engine, be aware of the limitations within whatever program that you're using and how you might have to work around those challenges.